All right, here we go with lesson 3 here in Unit 5, and I'll be honest with you going into this. Trig Identities is probably one of the most difficult topics we do. I'm not sure why. It's just something we struggle with. It does build off of proofs from geometry, which, we're a little shaky on, I think. We do a lot of the flow charts for proofs. We don't do a lot of two-column proofs, but regardless, hang in there. And I think probably the most difficult part about this is that no two examples are the same. So I can give you strategies, I can give you ideas, I can give you thoughts, but I can't do the problem for you. So the people that have the most success here are the people that just jump in and try and just start, substituting things, making changes, so on and so forth. And being a strong algebra student helps. So we'll kind of see how it goes, but bear with me and we'll give it a shot. I'll give you a sheet that has these identities on it. This is not something you're going to be responsible for memorize, and is not something you have to memorize for the test. I'll even give you the sheet for the test. You don't have to copy them onto a study sheet. But these are the identities, the basic ones that we're going to work with here in Chapter 5 at the beginning. There are more, but we're going to start with these. We have our tangent, cotangent identities. This is that definition of tangent. We know it's y over x, which is sine over cosine. Cotangent then is reciprocal, so forth. We do have the reciprocal identities. We know that these are all reciprocals of one another. So everywhere I see a sine, I could replace it with a 1 over cosecant. Everywhere I see a secant, I could replace it with a 1 over a cosine, so on and so forth. Then there's the Pythagorean identities, and this goes back to one of those triangles that we drew in the very beginning when we first started learning about sine, cosine on the unit circle. All right, we knew that this was the x side and this was the y side, and they made up that coordinate. Okay, we went on to say once we start talking about an angle here, we know that the x is actually cosine and the y is actually sine. Okay, and we call the hypotenuse r because it's also the radius of the circle. Because this is a right triangle, Pythagorean theorem applies. X squared plus y squared equals r squared. That was also the equation of your circles from Algebra 2. Well, if we know x is cosine and we know y is sine, that would tell us that cosine squared plus sine squared equals r squared, or in this case, 1, because we're talking about the unit circle. All right, now these are just variations of that. Okay, but that's sort of the skinny behind the Pythagorean identity. Let's take a look at a couple of these. First, if we're just simplifying expressions. Now, my tip, if you read that on the previous page, I didn't say it, is we're most familiar with sine and cosine. So my tip is always to take whatever we have and write it with sines and cosines. And a lot of times that helps students do a little better with this. So the sine, we're going to keep the same here, okay? But the cotangent, we're going to replace that, okay, with cosine over sine. Now, when we do that, okay, nice things happen for us. All right, a sine on top and a sine on the bottom cancel, which means this expression just equals cosine. So sine of x times cotangent of x is actually just cosine. Take a look at another example, number 2 here. Okay, we have secant, okay, which is replaced 1 over, try to color code this here. We replace the secant with 1 over cosine, because that's a reciprocal of cosine. We replace the cosecant with 1 over sine, because they're reciprocals. Now, again, it's bad algebra to divide by fractions. Instead, I multiply by the reciprocals, so I'm going to have 1 over cosine times sine over 1. And when I do that, I get sine of x over cosine of x, which I know by definition equals tangent of x. Again, changing things to sines and cosines makes this easier. Third, 1 minus sine squared. That's a variation of Pythagorean identity. That equals cosine squared. Anytime you see sine squared or cosine squared in the problem, you should automatically be looking at the Pythagorean identity. Now, if I have cosine squared over cosine, one of each of those cancels out, and I'm left with just cosine. Here's one that looks a little bit tougher. I have sine of t minus sine t times cosine squared t. All right, because both of these terms have a sine t in them, I can factor that sine t out. When I do, I'm left with the 1, that was the coefficient, minus the cosine squared of t. The cosine squared should be a giveaway that this is Pythagorean identity. I can replace the 1 minus cosine squared with just a sine squared. Sine squared times sine is sine cubed t. Last, cosine plus tangent times sine. The only oddball there is the tangent, so let's change that to plus tangent is sine over cosine. And I'm still multiplying it by sine. So what you'll notice here is I end up with a cosine plus sine squared over cosine. Now I'm sort of stuck, okay, and this brings up the whole "Are you a good algebra student?" catch-22, and that is if I can't do anything more, I'm going to have to add them together. And to add them together, I have to have common denominators. So that denominator is going to be cosine. Okay, and then I'll end up with a cosine squared and sine squared, which I know actually equals 1. So I get 1 over cosine. That's my reciprocal identity. That is secant x. So this big long statement way back in the beginning here is simply equal to the secant of x. And I use these steps and definitions to prove that. Now for a little bit tougher one, if I have a proof, I'm going to have to take the left side and make it look like the right side. Okay, you can really start anywhere you want with these. Typically I try to start with the side that has the most stuff going on. Just makes things a little easier. So again, I'm going to replace everything I can with sines and cosines. So that secant is going to become a 1 over cosine. Okay, the sine stays the same. On the bottom, the cosine doesn't change. I'm going to keep that the same, but I'm going to replace the cosecant with 1 over sine. Okay, I can simplify these. Sine times 1 is sine. So I get sine over 1, or sine theta over cosine theta. Okay, and on the bottom I'm going to get cosine theta over sine theta. Again, it's bad algebra to divide by a fraction. So instead of dividing by that fraction, I'm going to multiply by its reciprocal, which will be sine over cosine. When I do that, sine times sine, sine squared. Cosine times cosine, cosine squared. By definition, sine over cosine is tangent squared, which is what I was out for. I want you to go ahead and try the next one here on your own, and then come back and check, see what you get. So what I did here is replace the cosecant with 1 over sine, cosecant with 1 over sine. Again, it's bad math, bad algebra to divide by fractions. So I chose to multiply by the reciprocal of that. When I did so, I got a sine squared x minus 1, which looks an awful lot like the negative cosine squared. I know Pythagorean identity is going to be involved. What kind of part is it going to play? Well, in this case, I'm going to replace that 1 with sine squared plus cosine squared. By definition, Pythagorean identity. When I do that, I'm going to have sine minus sine, make 0. And then I'm going to have minus cosine squared, which is what I was looking for. Again, comes easy to me because I've done a million of them. Okay, the only way to get better at it is to just keep trying, keep plugging things in, keep, rewriting as sines and cosines, doing the best you can at your algebra strategies, and ask for help. Please ask for help.